to everyone. In this video, we have going to see about the beam elements. A beam is an structural element that load acting perpendicular to the beam's axis. Its mode of deflection is primarily by bending. So the beam will be considered as a structural element or structural member. Based on the loading conditions, we are classifying into a beam or bar. If the load is acting perpendicular to the axis, then it will be considered as a beam elements. If the load is acting perpendicular to the structure, automatically the deformations will be in form of bending. So that is called as a beam. So beams are classified into various types. So one is in cantilever beam, another is in simply support beam, overhanging beam, continuous beam, fixed ends, and then cantilever with simply support ends. So based on the constraints, the beam will be classified into different conditions. If the one end will be fixed support, all the degrees of freedom will be constrained, and another end will be in free, then it will be called as a cantilever beam. If it will be in simply support beam, the one end will be in hinged supports, and then opposite end will be in roller support. That will be called as a simply support beam. If overhanging beam, the supports will be in between of the structure. The ends will be in like a hanging supports, or it will be in cantilever free ends. Such type of supports, the beams are called as an overhanging beam. And then continuous beam, the one end will be in hinged supports, and then other ends we will provide in multiple supports for a different types of supports. For single beam, they are having a multi n number of supports, that will be called as an continuous supports. And then fixed beam, both ends will be in fixed. So both ends, the degrees of freedom will be in 0. That will be called as an fixed end. Another one is in cantilever with simply supported. So it will be a combination of cantilever and simply support beam. So cantilever, one end will be in all degrees of freedom will be fixed. So that will be considered for one end. And then opposite end, they are having a roller support. So they are having a only 1 degrees of freedom will be constrained. It will move in a linear motion. So such type of supports will be called as an cantilever with simply support beam. So these are the types of beams. The beams are classified based on the constraints. And then they're having a different types of loads. It will be generally classified into a point load or a traction force. If the force is acting a particular point, that will be called as a point force. If the force is acting throughout the surface, so that is called as a traction force. In the throughout the surface, the load will be in a uniform manner, then it will be called as an UDL load, uniformly varying load. If the load will be varying from starting to ending, that will be called as an uniformly varying load. So these are the types of loads or force acting externally to the member. This type of force are acting based on the loading conditions and structural member. Next, in a bar element, example distributing in it has been shows that it may be possible to develop a stiffness matrix using existing information and procedure available in the strength of materials. So what we are saying means the bar element is an example. It has been shows that the may be possible to develop a stiffness matrix. So here we take it as a bar element as an example. From that bar elements, we will develop a stiffness matrix by using an external information and product availability of strength and materials. So for that material strength, we are applying to a bar element equations. We will find the stiffness matrix of beam element. So that will be considered.